Is RV here? RV is not here. Shoya Jen, not here. Andrew Kang, not here. How about Huang Zhu, not here. Okay, so good evening, class. Again. So today we're gonna do section 4.4 and 4.5. I still haven't finished grading the test. I've been grading the test all afternoon long. So far, some of you really made it difficult for me to grade your tests. Okay, I give you plenty of time to scan and submit the test, and I told you to check your file before you submit it to me. And I don't know if you did that or not, but some of your tests were too light, not dark enough for me to grade. One test was scanned sideways and it did really hurt my neck. Okay, I literally had to grade like this, like why did you even do that? Okay, and when you made it that way, next time I will not grade it. Okay, and when I don't grade it, you don't get a grade for your test. Okay, you just need to show me some responsibility of your stuff. Okay, because like if I don't act on it, then you continue to do that, and it is not good for both of us, and it's a bad habit on your end when you do things without reading directions. Okay, so please make sure you check, because as I graded this afternoon, the test that made it hard for me to grade, I tend not to give as much partial credit as those tests that were neat and dark enough for me to grade. Okay, so I'm just telling you that. So you have to be more careful next time. Okay, unless you did all the work correctly, then you didn't even care about me giving you partial credit. But if your work, if your answer was wrong and I have to go through the steps to give you credit and so on, then I try to give partial credit to you guys, but you just made it hard. Okay, and even if your answer is correct and I cannot tell what you did, I wouldn't be able to give you credit because I don't grade based on answers. Okay. All right. So far, I just want to let you know, and another thing is, Math 78 is the hardest course for me to grade in general. The problems take me much longer to grade compared to calculus, right? So basically, the more advanced the math course is, the harder to grade. But the more advanced the math course is, the easier to teach. A lot of people think teaching algebra is easier. I don't think so. Okay, because the subject, yes, is easy, but teaching to the students, okay, is harder. So the lower the level of math is, the harder to teach, because you have to teach so that students can understand. And if they don't understand, then it's going to be hard. All right. Advanced math is much easier to teach, but it's harder to grade. Okay, because the problems are longer, they are harder, and it would be unreasonable to me. Okay, it would be unreasonable for my students if I were to grade based on right or wrong answers. Okay, so and I grade even for algebra. The way I grade is I grade based on your understanding of the problem. Okay, so sometimes students have a correct answer, but still get an F for the problem because the work just didn't make sense. So I would not give credit for a problem where the answer is incorrect, but student can get up to an A because, you know, the students made some minor mistakes somewhere in there, you know. And I said, well, that, you know, it's just a minor mistake. You know, the students understands everything. So I just give the student an A for that problem, okay? So as I return your test, you make sure you open the test, open the file up and go through and see what I wrote in there in red, so you can see, you can find out, okay? And if you have questions about my red comments on your test, then make sure you ask me. You can ask me during my office hours, or you can ask me, you know, whenever it is convenient for you. All right. Okay. But with that said, let's go to our lecture notes. Okay. So last time you told me that I uploaded up to section 4.6 on Canvas, right? So, you know, I will, over the weekend, I will try to get some more, couple more written, and then I put them up there for you, okay? Now, if we look at the schedule for our class, you see that I finished section 4.3 last time. So today we're gonna do 4.4 and 4.5. So probably this weekend I'm gonna give you another updated tentative schedule. So I'm gonna move everything up by 1 day, right? So with that said, I don't know if you like it or not, but instead of having the exam after spring break, now it's going to be before spring break. Now, you know, some people might like that, and some students don't. Okay, but you know, I just go with based on the pace. Okay, so right now that is what we're gonna have. So I'm gonna update this schedule, and then I post it on Canvas, so it's gonna be official. Now, some students, like I myself, when I was in school, I would love to have that test after spring break, right? So, you know, I would have an extra week to study. But over the years of teaching, a lot of students prefer having the test before a holiday or a long weekend or spring break. Because to them, they said, oh, let's get it over with, so, you know, we could enjoy spring break. My situation is kind of special compared to my students nowadays, right? Because back then, you know, I was very poor, right? No money. I live off like $5,500 a year, okay, paying it to tuition fee, rent, food, and everything. So in a way, I got nothing to enjoy, right? No money, right? So all I could enjoy was like being on campus, right? Learning things, playing basketball on a Friday, you know, for free, you know, no money. Okay, so the less holidays, the better for me, right? Because then all the people were enjoying, and you know, I was like suffering, right? No family, no parents, you know, it's sad. So I really hated Christmas, right? So I just wanted to be in school, okay, and get it done. My parents were all in Vietnam, so that's why, you know, whenever a professor says, "Oh, let's have the test right after Veterans Day or President's Day or after spring break," I was so happy. Yes, we have more days to study, right? Okay. And then when I started teaching, still said, "Mr. Klutz, can you somehow give us the test before spring break?" Okay. And I go like, okay, I would try, right? I would try, but I never want to rush when I teach, right? I said I would try. So if it is reasonable, I will do it before spring break. And then when sometimes students ask me, "Mr. Klutz, can we have it after spring break?" I said, wow, okay, now some want to have before, some want to have after. So I said, okay, how about let's vote, right? So I let the class vote, okay? And then sometimes they voted to have the test before, and sometimes they voted to have the test after. But for this class so far, I haven't rushed at all. Okay, so I take my time to teach you guys, and fortunately, because I prepare my lecture notes in advance, better this time. So it took me less time to teach in class. So that's why I was able to finish section 4.3. Okay, last time. Okay, so let's see how it goes. But for now, okay, that's what we're gonna plan for the test. That's when we're gonna plan for the test. Okay, before spring break. So hopefully we're not gonna rush. So you have enough time to study for the test, and you do well in the test, and then you can enjoy your spring break. All right. Okay. For my calculus classes, I have the test for right now is after spring break, okay, because they are kind of behind. Okay, a lot of them really need help with the stuff, so I kind of slow down a little bit. So I'm behind for my calculus classes. All right. Okay. So so that's the plan. All right. So make sure you check your Canvas accounts this weekend, all right, for the update. But I don't know, my OneNote is acting up. Okay, so today we're gonna do 4.4 and 4.5, and I don't know if I can finish 4.5. We'll see. Okay, so all right, so here is 4.4. Okay, so 4.4, we're gonna learn another way of solving differential equations. Okay, this time we're gonna solve non-homogeneous differential equations. Okay, and the method that we're gonna learn is called undetermined coefficients, but it is the superposition approach. Now remember the superposition principle that we learned in section 4.4, in section 4.1. Okay, so we're gonna apply that this time. Now, there is a glitch in this method. So I wrote the glitch in red. Okay, right here. So we're gonna take a look at the glitch. Okay, but let's go down the page and then let's see how this method works. Okay, so now if we have a non-homogeneous differential equation with constant coefficients, so all the coefficients are constants. And again, non-homogeneous means there is something on the right side instead of 0, right? So when we have a non-homogeneous differential equation, then the general solution of that differential equation is equal to a sum of the complementary solution and the particular solution. Okay, so those are all the things that we went over. Okay. Who just came in? I just admitted. Was that Thomas? Thomas? Thomas is not here.
He said that his mic doesn't work.
Oh, his mic. Oh, he put it in the chat.
Yeah.
Okay. Okay, because I have to keep attendance here. All right. So we talked about this one back in section 4.1. Okay, so now the way we find a complementary solution is the same, nothing different. For a particular solution, so that's what we're going to learn. That's what we're going to use, which is the method of undetermined coefficients. Okay, but today in this section we're gonna use the undetermined coefficients, but the superposition approach. Okay, in section 4.5 it's going to be undetermined coefficients, but a different approach. We're going to get to that. All right. So the way it works is this. So this is very important, okay? So the only way for this method to work is you need to make sure that the function g of x on the right side of your differential equation is a special type of function, okay? So how special is it? Well, the function on the right has to be like a polynomial, okay? So it could be a polynomial, all right? So in general, it could be any polynomial. All right, I don't know why I put a comma there, but okay, it should be. So it could be like in general, it's like any polynomial, like a one term or a bunch of terms, right? Like a constant x raised to a power. So make sure g of x is that, okay? Or g of x could be a function e with base e. Oh, never mind. That should be a comma, because that comma means it could be this or that. So it's comma. It's like when you continue on. Okay, so the function could be base e raised to a power. But remember, it has to be base e. All right. So if it is an exponential function but not base e, make sure you can write it as base e. If not, then you cannot use this method. Okay. Or the right side, or the g of x could be sine of something or cosine of something, and that's okay too. So far you see it could be any polynomial, it could be any exponential with base e, it could be any sine or cosine, all right? Or it could be a finite sum. I put final. It could be finite. Okay, finite. A finite sum and product of the above functions. So if you have like a sum or a product of these four types right here, that's fine too. Okay. So do you understand the condition on the function g?
I have a question.
Yes.
Does this like exclude like a tangent or a secant? Like
yes.
It does?
Yes.
Okay.
Okay, because if you have a tangent, that will be sine over cosine, right? We cannot have cosine on the bottom. So everything must be in the numerator, okay? So if you have like tangent, cosecant, cotangent, secant, then you cannot use. All right, so make sure you get
Okay,
that,
thanks.
all right? So, for example, so I'm going to give you some differential equations, and you tell me if we can use this method of undetermined coefficients. Okay, so how about this one? So for this one, what is your function g? So g, in this case, g of t, right? What is g of t?
3 to the power of t.
3 to the power t. So this is an exponential function. And what does the conditions, what are the conditions for g? It could be any polynomial. It could be any exponential, but with base e. Here you have an exponential function, but that is not base e. So do you think we can use the undetermined coefficients to solve? Or no?
No.
So you're saying that you cannot rewrite this one as base e?
Do the change of base.
Yes. Okay. How do you do that?
I don't remember off the top of my head.
Okay, you don't remember. All right. Anybody else can help Michael out? We want to write that as base e. Is it possible?
Wouldn't you need both sides as 3 first, and then...
Remember, we don't have both sides. We don't have an equation here. We only have 3 to the t. Okay.
I think you could do e to the power of 3 ln t.
Not
E
quite.
to the e
You're
to the
getting there.
power t ln 3.
E raised to what power?
T.
No.
Oh,
E raised to ln 3. What is e raised to ln 3?
it's just 3.
Just
So
3.
times
Just
t
3.
to the ln.
Okay, so that is what we want, right? We want, so that is the same as this. So if you raise t to the 3 to the tth power, then you have to raise this one to the tth power. Do you agree?
Yeah.
Yeah.
Okay. So what you have here is e. Now remember, you have e raised to ln 3 raised to the tth power, which means you just multiply the exponents together. So you multiply those together. Now you have base e. That's pre-calculus and intermediate algebra, right? Okay. So now, do you think we can use the method of undetermined coefficients to
Yeah.
solve? Yes. Okay. So that means the method of undetermined. I abbreviate. Okay. Coefficients can be used. Okay. Why? Because of base e right here. Okay, that's the reason why. Okay. Now, how about 2? What is the function g? So g here is g of theta, which is secant theta. And secant theta is 1 over cosine theta, which is cosine of theta and then raised to the negative first power. You don't want to write like this, okay? That is not cosine of theta raised to the negative first power. That's cosine inverse. So right here, and okay, this one right there is the problem. You cannot use the method of undetermined coefficients because that is to a power negative 1. It has to be to a power 1 because this is to the first power, you see? So that must be 1. Okay, so because it is not, then in this case, no. The method of undetermined coefficients cannot be used. Okay. All right, so the first thing you do is you learn to determine whether you can use the method or not. All right. And then next, you're going to learn how to use the method. So before we do that, let's recall the superposition approach. So here is what it says. So when you have a differential equation, this is the differential operator L, right? So you operate on y, and on the right-hand side is a g, is a function g of x. So in 4.1, the superposition approach says, if you have the same operator on the left, which is equal to a function g on the right, say g of 1, then this function is going to, so let's say the particular solution of this differential equation is y sub p 1, okay, to corresponds to the function g here, 1 here. And let's say you have the same differential operator on the left, but on the right-hand side, instead of this function g sub 1, you have a function g of 2. And the particular solution of this differential equation is y sub p2, all right? So the superposition approach says Then when you have the same operator on the left-hand side, but on the right-hand side, you get the sum of these two functions, then the particular solution of this differential equation is the particular solution for G1 plus the particular solution for G2. That's what it is saying. That is the superposition approach. Okay. So here it says, so that is going to be that plus this. All right. So now, before we use the method, let's determine. So now the following examples will help you understand how to figure out what form the particular solution has when you know the type of functions for the g of x on the right side. Okay, so the particular, so if you want to, you can write a note. Whatever the form that the function g is in, the form for the particular solution is or has the same form. All right. So g of x in this case is gx, is 3x. What kind of function is 3x?
Polynomial.
Can you be more specific? Yes, it is a polynomial, but what kind?
Linear.
A linear function, right?
Second order as well.
No. We don't say second order. Second order is referring to a differential equation.
Oh, okay.
We are talking about this function itself. This is a linear function. It is a polynomial function, but the degree of this is 1, so we call it linear function. So this is a linear function.
Okay.
Okay. Well, linear, which is a polynomial function, right? Okay, so that is actually a polynomial function. Polynomial function. So we know that the method of undetermined coefficients can be used. Okay. So you know that g of x is a linear function. So that means y sub p has to be a linear function. All right. So in this case, therefore, y sub p has to form. So you know y sub p is going to be, you say it has to form. What is the general form of a linear function? Y equals mx plus b, right? That's a general form, but we don't write mx plus b. You just say, in this case, okay. Remember, we only determine the form, okay? We are not actually looking for y sub p, because if I ask you to find y sub p, then you have to find out what a and b are, all right? We don't do that here. Okay, so we only want to get the general form for y sub p. Now for the next one, what is g of x?
Sorry, Professor, can you scroll up a bit?
Okay.
A bit more.
What do you need?
Just the one before that. Yeah, right there. Thank you.
The one before is right there, right?
Yeah, right there. Got it.
Yeah. Okay, so this one implies g of x. What is g of x? Class, I need your help. Okay, please don't make me wait. We are wasting our time.
An exponential function
Which is, in this case,
with base e.
base e raised to
3 to the x,
3x.
3x.
3x. Okay, so that is an exponential function with base e, right? So that's good. So we know that we can use the method of undetermined coefficients. Okay, so y sub p must be an exponential function with base e. Okay, so what is the general form of an exponential function with base e? The general form would be a e, okay, to the 3x. All right. So example 5. This time, the right-hand side, you have a sum of two functions. So the first one is like your g sub 1 of x. And this is like your g sub 2 of x, right? So we are using the superposition principle here that we were talking about. You see right here. So when you have a sum of two functions on the right, then your y particular is equal to the sum of the two particular functions correspond to those two functions. So in this case, you know that y sub p here is going to be the particular function for the first, for the g sub 1, and then the particular function for g sub 2. Okay, so what are they? So you look at this. All right, so so you know that your g sub 1 is what kind of function? It's a linear function, right? So this y sub p1 has to be a linear function. So write down the general form for a linear function, which is
ax plus b.
plus b. So I'm going to color code this so you know where that comes from, right? So that's your y sub p1. Now plus, then y sub p2 is the particular solution for e to the 3x. So it should be the general form that has base e, right? And we did that right there. So what should it be?
C e to the 3x.
Right, yes, right. We don't use a because it's saw a right there. We don't want to use it because we already used a, right? So now it's going to be c e to the 3x. Okay, so that is the particular solution for the second function g sub 2. So when we actually use the method of undetermined coefficients to find this y sub p, it's going to be something like this, where we know a, b, and c. Okay. All right. So now let's practice finding the form for y sub p for these functions g's. Okay, so you can practice. All right, so for example, if my function g is a constant, then my particular solution would be what? A constant, right? So just a constant, any constant. Okay, now for the next one, the function g is what kind of function?
Like linear function.
Linear function. So y sub p should be
ax plus b.
ax plus b. Next, the function g is a quadratic function. So my particular function should be a quadratic function. So what is the general form of a quadratic function?
Ax squared plus bx plus c.
Good. All right. Now, the next one, the function g is a cubic function. Now, remember all of these right here are polynomial functions. That's why we can use the method of undetermined coefficients, okay? So can you tell me what y sub p is for x cubed minus 5x plus 3?
Ax cubed plus bx squared plus cx plus d.
Be careful. Plus
E.
E. Why not D?
Oh, I don't know.
You don't know? You don't, I told you guys.
It's for
It's
determinant.
the differential
Is
operator.
derivative.
Yeah, capital D is a differential operator. You cannot use it for a constant. So you make a note right here. Do not use D, right, as a constant. Okay. Because it is a differential operator. Okay, I'm gonna write constant more clearly so you can see. Okay, the next one, some of you might not be able to get the correct YP, but just give it a try. Okay, so you have sine of 4x. So that is a sine function. So you expect your YP to have a sine function. Okay, so the general form for sine of 4x would be a sine of 4x. But this might shock you because it also contains something that is not like from the g of x. You see, because we work with differential equations, so they involve derivatives of y also, right? But here you have sine of 4x. When you find the derivative of this one, like let's say the first derivative is going to be cosine, and when you find the second derivative is going to be sine. So the sine and cosine keep alternating, right? So when you have sine or cosine for the function g, you expect your y sub p to have both, even though this one doesn't have cosine, but the yp should also have cosine because of the, when you find derivatives, they alternate between sine and cosine, okay? So this is something that you just need to remember. All right. And then for the next one, you see the function g is a cosine function. So you know your yp must be a cosine, and that is 5x. However, it should also contain sine, right? Okay, so you say that is b sine, okay? And then e to the 5x is an exponential function with base e. So y sub p should have something like that. So it's going to be a constant times e to the 5x. All right, so let's go back here. Go back up here. So you say it's right here. It said the condition says g of x could also be a sum or a product, right? Of these functions. So right here, you actually have a product. So you have a linear function times an exponential function. Okay. So for the linear function, it should be, the general form is a x plus b, right? Now for the exponential function, Okay, don't write this down yet. Okay, let me write down, explain it to you, and then I will erase something. All right, so you know that. So that's gonna be CE to the 5x. Okay, but remember, look at this. The C right here, when you multiply it to the A, they just give you another constant, right? And when you multiply it to the B, then you have another constant. Let's say like E and F here without the C. And because when you multiply to A and B, then you have like EX plus F. But EX plus F, you can just write A and B instead of E and F, okay? So you don't actually need the constant in front of the exponential function because that is absorbed in this constant and this constant. Do you understand that? Okay, so the same thing applies to the next one. Here you have a polynomial function times an exponential function. So what is the general form for that polynomial function? Class?
Wouldn't that one just be ax squared e to the 5x? Or the
No,
a?
what is the general form for a quadratic function? That is a second degree polynomial.
ax
AX
plus bx
plus bx plus c.
C.
Yeah, ax squared plus bx plus c. And then you multiply it to the general form of e to the 5x, right? Which is like a constant e to the 5x. Oh, no, a capital E and then e to the 5x. But that capital E, when you multiply to these three terms, they will be absorbed in these three constants. Okay, so you just need e to the 5x. Do you understand that? Okay, so you need, I just want to make sure that you guys understand why we don't multiply a constant in front of to the e to the 5x. Okay. Here you have a product of, say, oops, let me use a different color, of an exponential function and a sine function. Now, as of now, there's nothing here yet for y sub p. And you know that it must have an exponential function with base e. So you know the general form. Let's write this down, okay? So you can write on the side here for scratch work. You can write over here, okay? Or you can write over here, all right? But I'm gonna write right here for my convenience and I'm gonna erase it. So basically what you have is a e to the 5x, right? And then for the sine and the cosine, for the sine right here, here's the general form for the sine. So you should have a constant in here, sine of 4x plus c cosine of 4x, all right? But when you multiply the a here to this term, it's going to be absorbed in the b, and you multiply to here, it's going to be absorbed in that c. So you don't really need a constant in front of the e to the 5x. So you just have this, okay? And then for the sine of 4x, like a times b sine of 4x, you can just use another letter if you like, but I'm going to use a because I haven't. So in my final answer here, that is the first letter I use. So that's a, right? And then when you have the a times the c here, it's going to give you a new constant. I just call it b because I just used the alphabetical order, right? So that's b. Okay, so that gives you that form from the sine. Okay, see, if you understand how to figure out the general form for y sub p, you don't have to memorize this, but If you learn by memorizing, there will be a lot for you to memorize. That's why in the 80s, when I went to college, there was no such thing as a cheat sheet, okay? No graphing calculators, no computers, no smartphones, nothing, just a scientific calculator, all right? We were supposed to remember everything. So we have to learn a way or figure out a way for us to remember. And that way, in this case, is to understand where these come from, right? These come from the forms that we have here, especially for these right here. You need to also understand why there is no constant here for the exponential function, because when you multiply out, that is going to be absorbed in this constant. You see, so you need to understand that. Now, next, for this one, you have a quadratic function, right? And then a sine function, okay? So when you have a quadratic, this is more complicated, okay? So when you have this quadratic function, you know, it has the form ax squared plus bx plus c, right? And the sine of x, so let's go over here and do some scratch work. So you know that it's going to be like ax squared plus bx plus c, and then you multiply it to like e sine of 4x plus f cosine of 4x. Let's say you do it like this. But see, but when you multiply that to this one right here, the e times the a, the e times the b, the e times the c. Let's say if you use a different, let's say if you use lowercase letter, okay? So let's say a, b, c, right? So when you multiply e to those, you're gonna have, so e to the little a is big A, like that. And then e to the little b is gonna be big B. And then e to little c is gonna be big C. And then you have sine of 4x, all right? And then when you multiply that to this one, so you know the f right here multiplies to the little a, it's going to give you another coefficient, right? A constant. So that's why here you're going to have we use ABC, so now it's going to be not d, e x squared plus fx plus g. And then cosine, oh, I run out of space. So I'm going to write like that, okay? I should have written a little bit smaller, okay? So that is how you get that, okay? Wow, last one. You have a linear function, and you can expand further, right? Okay, but here you have a linear function, and then you have an exponential function, and then you have cosine. Well, what color should I use? I run out of color. Let's use purple. All right. So y sub p, I'm going to try to squeeze in here, okay? So we're going to have an exponential. So this one has two terms, right? So it has a cosine and a sine. So in front of the cosine, so this is ax plus b, but in front of the cosine, you have a constant. So when you multiply it to ax plus b, you're going to have new constants. And then this one also gives you a constant times sine. So that constant in front of the sine, you multiply it to ax plus b, you're going to have, new constants. So here's what you have. So you have ax plus b e to the 3x, and then cosine of 5x. And then when you have the sine of 5x, you have the constant in front of the sine of 5x. in front of the sign of 5x, you multiply it to the linear function, then you have new constants. So that's going to be ex plus f, and then e to the 3x sine of 4x. And then, we can expand more and more. So, I could give you a quiz on these things, right? I give you a function. I try to modify, just put combinations of these, and then I ask you for the form of a YP. Okay, wow, we haven't even know how the method works yet. Okay, so far we only know how to figure out the form of the particular solution. Okay, so again, I put it right here. I do not use the letter D, okay, as a constant again. Instead of up here, I write it down here. Now, let's go to this example. So here it says solve each differential equation using the method of undetermined coefficients, the superposition approach, if possible. Now, why if possible? It is possible only if the function g of x has one of those forms described above, right? So, and this is a non-homogeneous, okay? So you want to make it know this is a non-homogeneous. So for a non-homogeneous differential equation, the general solution has a YC and a YP. So let's find the YC first. So the complementary solution is easy because you just take the left side of the differential equation and you set it equal to 0. Okay. So from here, then right here, then the auxiliary equation is this. Right? So you just factor out m plus 2, m plus 3 equals 0. Okay. So we have, so right here we know m is equal to -2 or -3. So with that said, so what is YC? So from here, Y sub C is a constant times e to the negative. You write the smaller coefficient first, smaller constant first, and then the independent variable in this case is x, so it's x, and then plus c sub 2 e to the -2x. So you get y sub c. Okay. So nothing new, right? Now for y sub p, if you want to use the method of undetermined coefficients, superposition approach, then you need to know the form for YP. Okay, so what is the form for YP? So from the differential equation, then what is g of x? So g of x, let's just do it on the right side. Let's just do it on the right side. So g of x is equal to 3x implies y sub p is equal to a linear function. Do you agree? Which is ax plus b. Okay. So here is your differential equation. All right. So we are saying that yp equals ax plus b is a solution of that. So if it is a solution of that, then when you plug it in here, it has to satisfy this. Okay. So we know that. So this implies y sub p double prime plus y sub p prime plus 6y sub p must be equal to 3x. Well, you have y sub p right here. Just plug it in. But to plug it in, you need to know what y sub p prime and y sub p double prime also. So let's get the y sub p prime. So y sub p prime, which is the derivative of y sub p with respect to x. That's a, right? And what is y sub p double prime? Can you tell me?
0.
0. Okay, because
Roll up
a is
just
a
one line.
constant. A is a constant. So the derivative of a constant is 0. So now you're going to make the substitution. Y double prime sub p is 0. Y sub p prime is a. Y sub p is ax plus b. And that is equal to 3x. See, our goal is to find out what a and p are, because once you know what a and, well, I'm sorry, if we know what a and b are, we can get y sub p. So we can get the a and the b from here. So let's do it over here. So right here, that gives you 6ax. So we're gonna rhyme in descending order. Okay, so 6ax plus 5a plus 6b. I'm gonna group them. Why? Because they are constants, right? Okay, so remember, like for partial fractions, when you try to find those constants, you compare corresponding coefficients, right? So right here, you could write this one as plus 0. So we know that, so you know that 6a has to be equal to 3. And 5a plus 6b has to be equal to 0 because the corresponding coefficients have to be the same. So in pre-calculus, it says if two polynomials, again, are equal to each other, then their corresponding coefficient must be the same. So from here, 6a has to be 0, all right? And so let's write it like this. So 6a is 0.
Wouldn't 6a equal 3?
3, I'm sorry, it's 3, yeah. And then 5a plus 6b is equal to 0. So from here, a is equal to 1/2, right? So if a is equal to 1/2, you can get the b right here. Okay, you can solve. Okay, so you can just go to the side here. 5a. So that one right there, it's like 5 times 1/2 plus 6b equals 0. Okay, so that means 6b is equal to negative 5/2. So b, so b is equal to negative 5/12. Okay. Oh, right. So you have a and b. So what is?
So, can you scroll up just to the YC, please?
Okay. So y sub p is a, which is 1/2.
Thank you.
Sure. And then b is negative 5/12. All right. So we found y sub c and we found y sub p. So what is the general solution? The general solution is y equals y sub c plus y sub p, which is let me write down here. How about this? Let's write over here. So there's y is equal to c sub 1 e to the negative 3x plus c sub 2 e to the negative 2x, and then plus the y sub p, which is 1/2 x minus 5/12. Okay, then we get the general solution. Let's let me put it right there. So here is the answer. All right. So any questions on how to solve a non-homogeneous differential equation by using the method of undetermined coefficients, superposition approach? Okay. So this is the second method that you've learned so far, right? You've learned how to solve a differential equation, a second order or higher, by using reduction of order. So here's the second method of undetermined coefficients. Okay, now let's do the next one. So the next one, I'll find the YC. So for YC, you have Y triple prime plus Y double prime minus 5Y prime plus 3Y equals 0. So that gives you M cubed plus M squared minus 5M plus 3 equals 0. Wow. Now you have to figure out how to factor this out, if possible, right? And you learn how to do that in pre-calculus. Like, you know, in pre-calculus, you learn how to find all the possible rational zeros or rational roots, right? That means you take all the possible factors of 3, both positive and negative, and divided by all the possible factors of the leading coefficient, which is 1, right? So it could be 3 divided by 1, 3 divided by -1, -3 divided by 1, -1 divided by 1, okay, and a -1, and so all of those. So I'm gonna guess, right? So you know, I just want to guess the first one. So whatever that one is, I'm gonna put it right there for M minus. So I'm going to write, I use synthetic division. So I hope you guys still remember that. So here's how it works, right? So you write the coefficients of this. So that's 1, 1, -5, 3. So 1, 1, -5, 3. So whatever you think a 0 of this one is, you put it right here and you divide them out. And it is a 0 if you have a 0 remainder, right? So my guess, to make it say 1. Okay, let's see if it is 1. All right, so the way you do is like you bring the 1 down, and 1 times 1 is 1, right? You add them up, you get 2. 1 times 2 is 2. You add them up, you get -3. And then 1 times -3 is -3. You add them up, you get 0. Wow, that's good. We got it. So you know that this guy has to be a 0. So if it is a 0, then here you have M minus 1, right? So times what? These are the coefficients of the quotient. So it's going to be, well, this is M cubed. So this is going to be 1M squared plus 2M minus 3. Okay, if you don't remember this stuff, you have to review on your own, because I cannot reteach you the stuff that you learn in pre-calculus, all right? So this is very fundamental and elementary that you learned. You know, my beginning algebra learned this from me, and intermediate algebra learned this from me, and then also pre-calculus also, and then in pre-calculus you learn how to factor by using this, right? Break it down. So this is going to be, well, fortunately, this quadratic expression is factorable, so we can factor that. Okay. Okay, so excuse me, class. So here you have m equals 1, -3, or 1. Okay, so let's do this. The 1 here is repeated. Twice. So what is YC? So YC is equal to C sub 1 e to the -3x plus C sub 2 e to the 1x, and then plus, because 1 is repeated twice, then the next one is going to be C, right? C sub 3, and then you multiply x because the 1 is repeated twice. So you have that. Okay. All right. So now you see that if you didn't keep up with the page, you didn't do your homework, you will get lost here. You just wonder why that red X is there.
Professor,
Yes.
M must be a -3.
-3. Yes. Thank you. Yeah, I put -3 here, but no, I put a +3. Okay. So that's how you get the C. Now let's go to the YP, right? So to get the YP, you have to find out what G of X is. So G of X is this guy, right? So G of X has, so you're going to use the superposition principle. It has two different functions. So for this function right here, then you know your Y sub P has to be like A e to the -x, right? And then plus, and then plus G has sine of X. So this is a sum, okay, not a product. So be careful. If it was a product, then you would have multiplied like what we had up here in the table, right? Okay, in the table. But it is not a product. It is a sum. So you just use the superposition principle. So this is for the exponential, and now for the trig function, the sine, then it's going to be a constant times sine of x plus a constant times cosine of x. Oops. Well, how come it doesn't allow me to highlight? So that is my YP. So if I want to find out what A, B, and C are, I'm going to plug this into the differential equation, right? But in the differential equation, it also has y1, y prime, y double prime, y triple prime. So I need to find out what those derivatives are. Okay, so I need to find out what y sub p prime is. And that is actually -a e to the -x. And then plus b cosine of x minus c sine of x. Okay, so that's my y prime. Now y p double prime is going to be a e to the -x minus b sine of x minus c cosine of x. Okay, and then the next derivative is -a e to -x. And then plus c sine of x. Okay, now you're gonna plug them into, because y sub p is a solution of the differential equation. So when you plug it in here, okay, when you plug it in here, it's gonna satisfy this, right? So you're gonna plug in, so you get y sub p triple prime, y sub p double prime, y sub p prime, y sub p. Okay, so this is what you have. Okay. So this is what you do. So you know that y sub p triple prime plus y sub p double prime. Is it minus? Minus 5, right?
Yes.
Thank you. And then what is next?
3y.
3y sub p, right? Y sub p. And on the right-hand side, we know that that is e to the negative x plus sine of x, okay? So now we're gonna plug in. Wow, so be careful on how you do this. So let me skip a line to make it easier. So y triple prime is negative. So let me do, so it's gonna be, so it's negative a e to the negative x minus b cosine of x plus c sine of x, okay? So that is my y triple prime. Now plus y double prime. See, I'm trying to gather like terms, so I'm gonna put them underneath. So y double prime is a, so it's plus a e to the negative x minus b sine of x, and then minus c cosine, so minus c cosine of x. So that's my y double prime sub p. Now minus 5 y prime sub p. So you have to multiply these terms by negative 5, right? So when you multiply by negative 5, you're going to have positive 5a e to the negative x. So positive 5 is acting up. 5a e to the negative x, and then negative 5b cosine x, and negative 5 times negative c is positive 5c sine of x. So that's what I got from this term. And then I have 3 times y sub p. So here's y sub p. I have to multiply 3 to everything. So 3 times, so I get plus. So now I'm going to use blue. So plus 3a e to the negative x plus 3b sine of x plus 3c cosine of x. So make sure you write your capital C and smaller case c, lowercase c clearly, all right? So that is everything on the left-hand side. Now that is equal to this. So I'm gonna write like this. So that is equal to e to the negative x plus sine of x. All right, so let's simplify. Wow. Oh, low battery. Let's see. Wow, 5%. I've been timing and see how long it takes to drain the battery. It's 4 hours and 42 minutes. That's not good. That's not good. It used to last me more than 10 hours. And this laptop is 1.5 years old. So it went from like, I used to watch YouTube and stuff for 15 hours, right? Before I needed to charge. I think because I'm using Zoom, or at school I connected to to the projector to project onto the wall, so it drains the battery a lot faster, but not that fast. It's after a year and a half. All right, so let's simplify. So what you have, so you see like these two cancel out. So what you have is 8. Oops, you have 8a. E to the negative x. And then how about this? You have negative 6b plus 2c. Cosine of x. And then here you have 2b plus 6c, right? Okay. So now you're going to compare the corresponding coefficients. So the coefficients here of e to the x should be equal to 1, right? So what I have, I'm going to get 3 equations. So I have 8a equals 1. Okay. And then this one is the coefficient of cosine, and there's no cosine here. That means the coefficient of cosine over here is 0. So you know negative 6b plus 2c has to be equal to 0. And then the next one, that has to be equal to the coefficient of sine of x on the right. So 2b plus 6c. So 2b plus 6c has to be equal to 1. Okay, so from here, you can solve for a, b, and c. Okay, so it should be easy for you to do so, right? Okay, so right here you have a which is 1/8, right? Which is 1/8. B, you can get that. And C, you can get that. And then you can just get your y sub c. So you have the answer. So I'm going to let you do this, okay? So you can. Now, when you have like a larger system or more complicated system, you can use a calculator, graphing calculator. I showed you how to use a graphing calculator once, right? How to solve a system of equations, didn't I? Okay, so but here you can do that. So you have that, right? And so you can get the y. So y sub p is equal to whatever a is, right? Times e to the negative x plus whatever b is times sine of x, and whatever c is times cosine of x. So you have y. So you have y sub c and y sub p, right? So now you know the general solution is y sub c plus y sub p, which means okay, y sub c, we already have it up there, is c sub 1 e to the negative 3x plus c sub 2, I think that's e to the x, and then plus c sub 3 x e to the x, and then plus these right here, right? These, you put it right there, and then you get your answer. Okay. Now I want to go to the glitch when you use the method of undetermined coefficients, the superposition approach. And the glitch is the y sub p. When you come up with the form for y sub p, it might contain a term from y sub c, which is not allowed. Okay. Okay, let's go back up here to the objectives. All right. So when you come up with the form for your y sub p, okay, if the y sub p contains a term from the y sub c, which is the homogeneous solution or the complementary solution, okay, so that's case number 2. That's the glitch. So it says right here, okay, so for the method of undetermined coefficients, no function in the assumed y sub p is a solution of y sub c. In other words, for example, if y sub c is equal to, say, something like this, right? And then when you get the form for y sub p, then you have like a e to the 3x plus 4x or plus cx plus bx plus c. Then you cannot do that because this term of the y sub p is already in the yc. Okay? Does it make sense? So when that happens, then what you're gonna do is, instead of a e to the 3x, you multiply x to e to the 3x and see if that term is not in the y sub c. If you multiply the x right here and you still have that in here, then you multiply x squared. You continue to multiply x raised to a power until it is not contained in the y sub c. So that is what this is saying, okay? All right, so that is the glitch. And I'm telling you, in the past, it didn't matter how many times I warned the class about this, and they still did not bother, okay, to check. So for example, like in this case right here, like where, let me go there. Like for example, like these right here, right? No, not those, like down here, like these right here, right? So when I give when I give you an equation like this and they say find the form for y sub p without solving, you don't just find the form like this, okay? Because in order for you to get the correct form for y sub p, you need to find out what the complementary solution first. So you know what terms are in the y sub c, so that when you get the form for y sub p, that the terms of the y sub p are not contained in the y sub c, okay? So let me demonstrate that for you. So it's very important for you to remember that, because if you make a mistake like that, it is not a minor mistake. It is a major mistake. So you lose a lot more points when you do that. So for example, in this case, okay, so even though, see the problem, it doesn't tell you to find y sub c. It only asks you to determine the form for y sub p. All right. You know the form for y sub p is going to be a e to the x, but you cannot do that yet. Okay. So before you do that, we need to find out y sub c first. So we need to find out y sub c first. Okay. If you want to, you make a note right here. Why are we doing this? Just make a note right here. To determine, to see if there is a glitch. Okay. So So you to determine to see if there is a glitch. That is the reason why you are finding the y sub c. We don't know that yet, right? So we're going to do this. So y, so the auxiliary equation is m squared minus 5m plus 4 equals 0. So you factor out, so that is m minus 4, m minus 1, okay? So m is equal to 401. So what is y sub c? So y sub c is equal to c sub 1 e to the 1x plus c sub 2 e to the 4x. Okay, so what is the glitch? The glitch is if y sub p is equal to something that looks like this term or this term, then that is the glitch. Does it make sense? So whatever y sub p is, make sure it doesn't contain e to the x or e to the 4x. All right, so let's find out. So for y, so we want to find out y sub p, right? So first, let's get the g. So let's figure out what g of x is. So you know g of x is equal to 8 e to the x. So that means y sub p is equal to a e to the x, right? Is that good? Is that y sub p?
No.
No.
No, because e to the x is contained in c. See right there? So this term so that is the glitch. So how do you remedy that? You multiply by x, okay? So we try, so y sub p is equal to a, and you multiply e to the x by a factor of x, and check again. And check. Now check and see if this is contained in the y sub c. If it is still in y sub c, then you have to multiply by x squared instead of x and continue that pattern, okay? But make sure you check. So this is not in there, right? So x e to the x is not contained in y sub c. So that's good. So this is the form for y sub p. Okay, so that is the glitch that you need to watch out for. Okay, now let's do this. So first, let's get y sub c. So the auxiliary equation for this is, let's do it over here. So this m squared minus 2m plus 1, okay? So that gives you, so m equals 1. Repeat it twice, or you can write multiplicity 2, right? Okay, so what is y sub c? So y sub c is c sub 1 e to the 1x plus c sub 2 x e to the 1x. So that's y sub c. You don't box it because I am not asking you to find out y sub c. I only ask you to get the form for y sub p. Do not find the constants. Yeah, by the way, you know, one student so far that I have noticed didn't read the direction carefully, and so for one of the free response questions on the test, what is that, the mixture prompt, the tank, right? I only asked to set up an IVP, and you set it up and you were wasting your time solving the IVP, and it took you a long time. Okay. So what is y sub p? So first, you know that g of x is equal to e to the x. So you know y sub p is going to be a e to the x, right? But can you use it?
No.
No, because it is in here. So no, no, y sub p is not that. So what do you do now?
Multiply by x.
Multiply by x. You multiply by x and check again. Is that contained in y sub c?
Yes.
Yes, right there, right? It's right there. So no, this is not good. So what's next?
Multiply by x again.
Yeah, multiply. So that should be x squared, right? And then e to the x. Is that contained in y sub c?
No.
Okay, so you say, all right, so you say x squared e to the x is not in y sub c. So that's good. So this is the form for y sub p, okay? Okay, we're gonna stop because I have only about half an hour no, is it half an hour? Not even, right? We end at what, 7:50? Oh, so we don't have much time. So I wanna go to the next section, okay? All right, so let's stop right here. You can try and do this one, okay? Try and do that and see if you can come up with y sub p, and then you can ask me during my office hour, like after class next time, and I can tell you, okay? But let's say we are done, okay, for that section. So I'm gonna get started on y 4 sub 5, and then we will continue next time. So this time, in this section, we're gonna solve non-homogeneous differential equations by using the method of undetermined coefficient again. But this time it is not the superposition approach, but it is the annihilator approach, okay? So what is the annihilator approach? We're gonna get to that, all right? Okay, so again, I give you this non-homogeneous differential equation with constant coefficients, okay? And then we can rewrite this one by using a differential operator L, right? So we write everything here is like L operates on Y, and where L is this guy, okay? So this, everything here is L, okay? So L is called a differential operator. So now what is, oh, you know what? Oops, what happens? I always use the yellow to highlight the name of the topic. So I want to highlight this in purple. like that. Okay, so I'm missing right here an annihilator of a function. Okay, by definition. So an annihilator of a function is a differential operator such that when you operate that annihilator on the function, we get 0. Okay? So for example, if I give you a function f of x equals 5, and I ask you to find me an annihilator for this function, that means I ask you to find me to find a differential operator such that when I operate it on 5, I get 0. What differential operator can you operate on 5 and you get 0?
The first derivative?
The first derivative, very good. So here you say the first derivative, we use capital D, right? If you operate it on f, that is the same as operating on 5. And you know that the first derivative operates on 5 is 0. Okay. Now, when you do the derivative here, then it is understood to be the derivative with respect to x because x is the independent variable. Okay. So when you do this and you get 0, then we say D is an annihilator of f. Do you think D square is also an annihilator? By the way, what does it mean by D square?
Second derivative.
Second derivative. Do you think D square is an annihilator of this function also?
Yes.
Yeah.
Yes,
Yeah, because
right?
it's still 0.
Or any higher derivative would be an annihilator of this function. Agree? But we want to get the simplest annihilator. In this case, it is the D. Okay, so this means D is an annihilator. Oops. Of f of x equals 5. In this case, it's like, you know, you want to find a differential operator that would annihilate the function f. That, you know, if you literally it in English, it means like you get rid of it, right? Okay, so that's what it is in that's what it means in differential equations. You want to get an annihilator. To annihilate a function, that means to get the derivative of the function to be 0. Okay. So what do you think would annihilate x squared?
Third derivative.
Third derivative. Because if you use the second derivative, then the answer is going to be 2, right? And so it's not 0. So you have to do one more derivative to get rid of the x squared. So in this case, if you do third derivative of x squared, you would get 0. Okay, so that means D cubed is an annihilator of the x squared function. Okay. What about 24x to the 21st power?
22nd derivative.
22nd derivative. Very good. Now, if you don't believe me, do that. Okay, find the derivatives 22 times. of this function, and you will see. Because basically 24 is the coefficient, so you can just pull the 24 out, right? So you just take the 22nd derivative of x to the 21st. You're gonna get 0, and then 24 times 0 is 0. Okay, so that means is an annihilator. Okay. All right, now, what do you think? What is your guess for e to the 2x? What do you think would annihilate this? You might want to try to do some work, right? So you might think, oh, let's find. So this is what you do, okay? If you look at the problem and you don't know what to do, whatever you are thinking of, write it down, okay? So you can try the first derivative of this and see what happens, okay? So you can try, all right, so let's take the first derivative of e to the 2x. What do you get?
2 times e to the 2x.
Okay. You don't want that. You want it to be 0. Do you agree? Let's try this. How about when we move that to the left, we get 0, okay? Then from here, you know what? Let me do this. So I have some room to work with, like this. Okay. All right. So from here, you can factor out the e to the 2x like that. Do you agree with that?
Yeah, that makes
This is
sense.
the same as that, right?
Mhm.
What are we trying to find? We are trying to find a linear or a differential operator such that when you operate on e to the 2x, you get 0. So what is operating on e to the 2x in this case to get 0?
D minus 2.
D minus 2. Okay. So in this case, we say d minus 2 is an annihilator of e to the 2x. So d minus 2 is an annihilator.
Professor?
Yes.
So I'm sort of confused because what you just did is you took a function, which is the derivative, and a multiplication, which is the 2 times, and you sort of made them together. But the thing is one's a function and one's just a multiplier.
Right, and we are operating on this. Okay, I know the confusion. Okay, but let's go back and see how we defined our differential operator. Okay, let's see up here how we define the L. You see it right here. That's like, so this is multiplication right there. You see, and this is like d. So this is like d dy, and this is a naught times y. But the way we define that is then we can just factor out the y, and then we just write the leftover in this expression as this. Okay, so we can actually combine an operator and also a coefficient, a factor, together to get an expression, and we call that a differential operator. So it is just from here. All right, so and that's how we define the L. So Michael,
That makes
Is
a
it
little bit
okay?
more sense now that we went over
Okay.
the definition.
Okay,
Thank
and
you.
then you can also go back to section 4.1 and see how we started like a little bit before the L to get that, right? So yes, because right here, but it's a very good question. I'm glad you saw that. Okay. So because you notice, okay, wait a minute, this is like an operator. That is a differential operator. So and this is just a multiplication. That is not a multiplication. So how were we able to do that? So you can look at this multiplication as an operator also. You operate 2 on that, so 2 times that. You operate this on that. So both of these are operating on e to the 2x. Okay, they have different functionality, right? This operator is a differential operator, and this operator is a multiplication operator. You see? Okay. So right here, when you write this one as that, you say, all right, so this I know is a differential operator. That means I'm going to operate on this by taking the derivative. And this is a multiplication operator, so I'm going to multiply that to this one. I hope that that makes a little bit more sense. Okay. Now, what is your guess on this example?
D minus 5.
D minus 5. Okay, very good. So you can see the pattern. So you know that D minus 5 operate on this will give you 0. Okay. So D minus 5 is an annihilator. Of. So from here you can come up with a formula for the E already. So what if I have e to the alpha x? So what is an annihilator for e to the alpha x?
D minus alpha.
Yeah, there you go. Okay. So you look for a pattern, so you can come up with a general rule for an annihilator. Okay, and like for polynomials, you know that if the derivative is 1 higher than the exponent of the polynomial, then you can annihilate it, right? Okay. And here, if you have an exponential function, then an annihilator would be d minus whatever the coefficient of x is in the exponent. Okay. So now, what about this one? Well, I guess I'm going to stop right here. Okay. I guess we have done a lot already. Okay, so let me just stop right here, and you can go further and read this, and then next time we're gonna finish up. Okay, so this week I gave you a break after the test last week, so no quizzes this week, right? So next week I might give you I will give you an in-class quiz, and might also collect some homework. But right now, so when I collect the homework for a quiz, I don't announce in advance. You need to, if you are here and you have your homework, you turn in. If you're not here, you get a 0. Okay, because that would encourage students to come to class. But here, let's say so on Monday next week. So okay, this is going to be here. All right. So on Monday next week, we'll have quiz number 6B. So what section is going to be? So how about 4.2 and 4.3? Okay, should be easy, right? 4.3 is finding y sub c, and then 4.2 is like very reduction of order. Okay, guys.
Do you mean you're collecting those homeworks or giving a quiz on those sections?
No. Like I said, if I collect the homework, I'm not going to tell you in advance. Okay. If I give you an in-class quiz, that I let you know in advance, which is this one right here, in-class quiz. Okay. All right. So again, for those of you who came late, I announced to the class that our next test is going to be before spring break. Okay, so move it to this date. So again, make sure you go to Canvas and check and look for a new tentative schedule, an updated tentative schedule. So I think if you set the notifications on Canvas on your phone, anytime I do something to the class, then it will alert you. Okay, so you won't have to miss anything. Okay, guys. I have talked too much, right? I guess I talked too much and you guys wrote too much, right? You have to take note. Not too much. I wrote a lot of stuff for you already. Okay, I maybe said, oh, my brain worked too much. I have to think. Okay, when you lecture. Okay, but that's good. That makes you work. All right. I see you all next week and enjoy your weekend.
Professor,
Yes,
is the quiz going to be multiple choice or free response?
it could be either. Okay.
Did you say it's on 4.2 and 4.3?
Yes, 4.2 and 4.3.
Thanks.